In this model, we're going to examine the difference between a push system and a pull system using Kanbans. So we've set up a very simple manufacturing system here where the green workstation produces parts at half a second per part. They travel 10 seconds down the conveyor, and then the blue station can process those parts at 1.25 seconds per part. We're going to do a 100-part run, so we're going to make 100 parts. And if the blue machine finds any defective parts that the green machine produced, it will immediately tell the green machine about it, and the green machine will correct the problem. So we're interested in how long it will take before we detect the first bad part on the blue machine, and also how many bad parts would be produced. In this particular model, I've got it set up so that the green part will start producing bad parts after the 30th part. So let's go ahead and run the model, and kind of just hit the play button, and we're producing good parts. They're traveling along, and the blue workstation's working on them. It doesn't go as fast as the green, so they're queuing up. Now we see some bad parts are coming. The green machine's oblivious and just keeps producing, because it's pushing, it's not pulling. It's going to go until it gets 100. It's got about 45 bad parts now produced. 25 good ones have been released. And there, okay, the blue machine just caught the bad part. It looked like after about 33.8 seconds, and it looks like it made about 70 of them. Now, it told the green machine that the bad one was there, so the green machine just started making the good one again. But in the meantime, we have, it looks like about 69 or 70 bad parts in the system. So probably not the best way to go. So let's go ahead and get ready to do the next run. And in this one, we're going to do a pull system. We're going to use 10 Kanbans, and we're going to have the green machine produce just like before, and just like before, it's going to start producing the first bad one after 30 parts. Except this time, we're only going to allow 10 parts to be made that are either on the conveyor, in the queue for the blue machine, on the blue machine, or being produced in the green machine. If there's more than that, you're going to see this production status is going to go red, meaning the green machine stopped producing on purpose, and it will wait till the blue machine catches up a little bit. So let's go ahead and run this and compare the two. So I'm going to hit the play button, and so it's going to produce parts just like before. So I'm going to pause it. Now here you notice we got 10 because that's how many Kanbans we have. So each K is a Kanban, they're all being used, and the green machine stopped producing. It won't start again until some of those Kanbans are freed. Okay, so this here part lost its Kanban, and the Kanban was sent back to the green machine, and it produced another part using that. So it's recycling the Kanbans. So now it's only going to start producing when there's a Kanban allowing it to produce. So you see already we've got a much better system than we used to have. If you look at the red, that's from the push system, how many bad parts were produced. And notice so far we don't have any bad parts produced yet, because we're not producing as quickly. We don't need them as quick. Now we just made our first bad part. And let's see how long it takes for the machine to capture it. Okay, there it is. Okay, so it took about 12 seconds to capture the first defective one, whereas before it was 33.8. Instead of making about 69 of them, we've only got about 10 of them made. So, and we both produced the same number of good parts, by the way, because the blue machine was never starved for parts once the first part reached it. So we were producing just as fast, but not as many bad ones. So a much better situation. Let's go ahead, clear that out, and let's take a look at what else we could do. Well, there is a very long distance between the two machines. Let's see if we were able to work on our layout and get that reduced, what would happen. So let's go ahead and look at reduced travel and run the same thing. Now, because there's less space between the two machines, we don't need quite as many Kanbans because there won't be as many stuck on the conveyor. So let's go ahead and run this. And notice how much quicker it is to look at recycle those. And we've already produced 7 parts, whereas the first 2 are just starting to produce. Now scenario 1, this is where it started to produce defectives. And pretty soon this one should start. Give it a little bit. Okay, there's the defective. Okay, I'm going to pause it. So here it's already told the machine, hey, I found a defective. Stop giving, fix your problem, start making good ones again. So that's what that machine's going to do. So it started catching the defectives after about the same time, though. But it corrected them faster. Or started making them at the same time, but started to correct it faster. So this is why the green scenario, which is this scenario, is doing much better. So you can see now as a result, we've got only about 4 or 5 defectives produced as opposed to about 10, and we caught it much quicker, and we've produced a few more parts. So just a few simple changes, we really improved our system a lot. For such a simple thing that we're doing. So I'm going to give you a minute. Think about what else we could do. We're done with the simulation part of this exercise, but we could open it up to discussion and think about what else you could do to improve this. And I'm going to go ahead and you can pause the video if you want. I'm going to go ahead and open up another slide now that shows some of my ideas. And if you have any better ideas, let me know. So let's go ahead and open up discussion. What else could be done? Well, you could have the operator inspect his own work instead of waiting till he gets to the next machine. And one way to do that is to not do 100% inspection, but instead use statistical process control. And this way you could catch the bad parts before you make them. So instead of inspecting them afterwards, you inspect them before you produce, and you could see, oh, my machine, this critical value is starting to get to the control limit. I know the process is going out of control. Very quickly I should start making adjustments. So you could use the statistical process control to not make the bad parts. And that would, of course, an even better solution is to find out the root cause. Can you correct the problem so you don't make the bad parts at all? That would be the best thing to do, of course. Now, of course, whether that's easy to do or not depends on what it is you're actually dealing with. One thing to note that the Kanban, Toyota Kanban rules say that you should always be making good parts. So it's very important, I think, to find out why those bad parts are being made, because the Kanbans don't work as effectively if you start making a lot of bad parts. So that's a very important note. So with that, I hope you enjoyed the simulation model.